Shalom. I'm Doug Seserman, CEO of Americans for Ben-Gurion University, and welcome to a special Monday Hanukkah edition of hashtag Webinar Wednesday. But today on this Monday, the second day, actually the first day of Hanukkah, but tonight will be the second evening, we are celebrating the ultimate light that Israel brings to the world through the introduction of the first of its kind BGU's new School of Sustainability and Climate Change. And we have an incredible panel with Yaron Ziv, Sigal, Abramovich, and Osnat, Gillor. Before going into the panelists, I just want to thank all the participants. We had more than 180 people register for this webinar. And also thank the incredible Melody Mokhtarian, Leora, as well as Ali, who are working so hard behind the scenes to curate these webinars and bring them to our audience. So this is great. We also had 17 community partners that helped get the word out. So we have a couple of slides of the different community partners. Thank you, Leora, for showing those partners. And remember, our goal is to collaborate with organizations around the country to bring the best of Israel right to your home organization. So please join us, and we'll work with you to visit BGU, whether that's in person or virtually. Today there's a travel ban, so we can talk about that later maybe. But our job is to raise awareness for the remarkable Ben-Gurion University and the best of Israel in the modern world, which really is what this school represents. Okay, so this last webinar, we tried something and got positive feedback, so we're going to try it again. We're going to start this webinar off with a poll question. Today's poll question, first poll question, is what was the hottest month ever in the history of the world? And our audience is pretty bright out there, panelists. July of 2021, correct. Over 2/3 of you got the answer correct. This is obviously a sign that something is happening with the climate. All right, great. Okay, so I think we are now going to move into a second poll question. Is that my understanding? No, we're going to stick with that first poll question and go straight to the panelists because we've got such great panelists. So we're going to start with Professor Yaron Ziv, who is the head of this new School of Sustainability and Climate Change. And Professor Yaron Ziv was BGU's chairperson of the Green Campus Initiative for 5 years before taking on this new role. He works as part of the Department of Life Sciences, which is part of the Faculty of Natural Sciences. Yaron is a community and spatial ecologist who studies evolutionary and ecological drivers of biodiversity processes and patterns of different spatio-temporal scales. Yaron's Spatial Ecology Lab explores diverse hypotheses regarding the distribution of organisms in several heterogeneous and fragmented model ecosystems to understand how species/environment relationship affects individuals, populations, and species. Yaron's lab also involves in conservation issues and practices, including rare species preservation and management, ecological restoration, and agroecology. He is highly involved in conservation decision-making and education activities through serving on national and international committees. Among other organizations, Yaron is currently a member of the Managing Committee of the Society of Protection of Nature in Israel and a member of the Man and Biosphere Committee of the Israel National Commission of UNESCO. Yaron received his bachelor's from Tel Aviv University, his master's from our own Ben-Gurion University, and did his PhD work at the University of Arizona in the States. He also did postdoc work at the University of New Mexico. Welcome, Yaron.
Thank you very much.
Okay, so I see that you've already loaded your PowerPoint. For our audience, each speaker is going to present a little bit of a PowerPoint presentation, and everybody understands the format. So if you have questions, just click on the Q&A function, and we'll feed those questions to the different panelists. This webinar is called for an hour. So at the end of the program, we'll open it up to everybody. Take it away, Yaron. Tell us about your work in this new school of sustainability and climate change.
Thank you very much, Doug. And I'm really delighted for this opportunity. And I hope I'll be able to convince you that we're doing a good job by establishing a new school of sustainability and climate change. Of course, the presentation is in English, but for loyalty, I will keep my Israeli accent, if you don't mind. So we all are quite aware that we are facing an environmental global crisis, and we all are aware of the climate crisis, like global warming, sea level rise, climate instability, extreme events. You know, we heard about floods in Germany, very hot days in Canada, California, fires, and a lot of disasters all over the world. But the climate crisis is not alone. There is also an ecological crisis with habitat loss and degradation, disturbed ecosystem, loss of ecosystem services that we, the human beings, enjoy from biodiversity decrease and extinction. And you can imagine that the two crises are not independent. They feed each other and they interact. And overall, due to this crisis, we are affected and have negative effects for, you know, health, agriculture, food security or insecurity. And we're strongly affected negatively by this crisis. Now, I had the opportunity, I don't say I had the pleasure, it wasn't really a pleasure, but I had the opportunity to attend the climate conference in Glasgow 3 weeks ago. And I was in the Israeli delegation, a representative of BGU. And basically this conference came to look, among others, at the adjustment needed to the Paris Agreement in 2015, and to find out what we need to do in order to make less effect or bad things to our globe with respect to mitigation and adaptations. And it is clear, and this was the conference, that it came with understanding that the world faces a dramatic moment with the last opportunity to prevent humanity from catastrophe. And people understand it, and the leaders understand it too. Now, when we look at the targets, the 4 targets before the climate conference stated by the United Nations, there were secure global net zero by mid-century and keep 1.5 degrees within reach. The second is to adapt to protect biodiversity and natural habitats. The third one, the third target, is to mobilize finance, and we're talking about $100 billion that are supposed to move or transferred from the rich developed countries to the most vulnerable and poor countries in order to help them with the climate change and work together to deliver and change some economic models and the interaction between governments, businesses, organizations, companies, and so on. Now, when we think or we consider that the end of this conference, and we now compare what we know 2 weeks later. So first of all, unfortunately, in an utopic, very optimistic world, if all the commitments by the countries are followed and everything is okay, the UN experts and others from all over the world predict that we're not going to stay in 1.5 degrees. We're already talking about 1.9 degrees, and actually a very reasonable scenario talks about 2.4 degrees Celsius above the post-industrial revolution period. So this is really, really bad. And if we understand and know what is going on, there are low chances that the countries are going to stand behind their commitments. We know what happened between Paris Agreement and Glasgow conference. So these are not good news. With the second one, we are far from where we need to be with respect to biodiversity and ecosystem functioning. And it was a big disappointment for me because this is my area of expertise, and that's definitely not going to happen. Talking about deforestation, but not enough. The countries or the United Nations failed to reach the $100 billion transfer from the rich countries to the poor ones. And there are many problems with a lot of international politics involved. We're not seeing the end of that. And when we talk about the new economic models, again, we are far from where we need to be. There is no real progress. Unfortunately, I was not very optimistic after this conference. However, on the other hand, it made me understand that we need to work hard and to do what we can do with respect to keep our sustainable world and work on sustainability. And when I talk about sustainability, I'm talking about the processes and actions through which mankind avoids the depletion of natural resources in order to keep an environmental balance for future generations. And this is where we are going in our school, and this is what we want to do, to work on sustainability. I like this Brundtland line that sustainability is meeting the needs of the present generation without compromising the ability of future generations to meet their needs. And it is clear that if we want to work on sustainability very seriously, we have to understand that sustainability is not only water, air, or soil, but it is also other aspects like social and economic ones. So we have to think not about only pure or clean water, which is really important, but also to think about behavior, decision making, philosophy, policy, health, and other issues. So sustainability requires a broad perspective and inter and multidisciplinary approaches. Now, when we think about the academia and academic institutions all over the world, it can be Ben-Gurion University, Tel Aviv University, Michigan, Washington, Harvard, Yale, it doesn't matter where. Usually academic institutions are organized quite vertically. In other words, we have a rector or a provost. Underneath, we have some faculties or colleges. Under each college or faculty, we have departments, and underneath, we have programs and so on. So it's very vertical, and it is important because it gives us the option to work in depth on specific aspects. However, if we want to work on sustainability as an interdisciplinary and multidisciplinary perspective, this demands a different structure of academic organization, not at the expense of what we already have, but in addition, in a different structure. And this is what we're doing at Ben-Gurion University. We realized that we need a school that will bring together and bridge between different disciplines with faculty members from different academic units. So the school at BGU aims to be a leading hub of multidisciplinary research and education, providing viable solution, adaptation strategies, and policies for present and future environmental challenges. And we have different missions or goals, like to advance knowledge by bringing expertise across disciplines to work together on crucial and important issues of climate change and sustainability, to function as a central source for faculty, postdoc students, and alumni that want to move on with these issues and do some work in sustainability and environmental sciences, to train undergraduate and graduate students and prepare them to be future leaders by offering robust interdisciplinary programs. And I'm going to mention a few degrees that we are now working on. And the idea is not only to give the students the best training, but also to make them leaders or ambassadors outside of the university to explain why sustainability is so important and where we are right now. We want to take part in formulating national and international policies, and we already do that. And we have some interaction with governmental offices to share knowledge and ideas with the community. And you know quite well, I guess most of you, that BGU for many years is quite known by the relationship and the community-oriented university. And we want also to share our knowledge with the community and to want to promote collaboration with industrial and governmental institutions, as well as with international organizations for fostering innovative ideas and solutions. So we have
now Yaron, this is a really great slide, and I know we've been getting questions from the audience and other people just asking, how is this new school different from what we've done before?
I know I'm going. This is exactly where I'm heading. So if okay.
Perfect.
Okay, so just to mention that BGU is already strong in environmental sciences and in the recent years also in sustainability. So we're starting from a quite good starting point with sustainability and climate change issues. These are different topics, and now I can talk about the school, and this is exactly the answer you were looking for, Doug. So this is the organization or the structure of the new school. The school is located or nested under the rector office. Under the rector office, it is not a faculty by itself. It is not a different academic unit. It sits under the new interdisciplinary teaching unit under the rector, because it works as a cross-faculty framework. So I would like to emphasize that and to explain that we're not building a new faculty. Actually, the second point I would like to emphasize is that the school council, the parliament of the school, if you want, is composed of faculty members from different high academic units, in other words, from the 5 faculties and the institutes for desert research. So the faculty members do exactly what they did before, and they keep doing it, and they do a wonderful job, but they have affiliation with the school council. I'm very happy to say that we already have 150 members, faculty members from the different academic units from many departments. Now, these faculty members also are part of the school's committees, and we have 4 committees, each represent the different directions where the school is going. And I'm going to say a few words about it in a second. Before I forget, we also work now to establish a new international advisory committee, and we really hope that leading environmental scientists and professionals from all over the world will be part of this committee, so we'll be able to get advice and work with these guys to make a better work and improve our school. Also,
Yaron, we're getting a question from Philippe Mouchard. First of all, he says he loves this initiative. And he's asking if you could give just a couple of maybe concrete examples of what you might see from an academic standpoint or from a research standpoint in maybe the first year or 3 years out.
Okay, wonderful. And this is the next slide. This is the next slide, but before I go to the next slide, just I would like to mention that in about in the future, we also hope that if we have enough resources to create or establish new support centers to bring together scientists from different faculties. Now, if I move on now to the the research where I can show some example. So first of all, we want to provide research opportunities, like new academic forums that we don't have, because now we have academic forums within each faculty. We want to have something which is more interdisciplinary that comes on top of, or in addition to what we already have. We want to assist with grant submission, and this is another example. Sometimes there are big grants and we don't have enough resources within each lab, in each faculty, or we want a collaboration, collection of faculty members. This is something that we haven't had before, and we can do it now with a new school, which is a cross-faculty framework that is built exactly to deal with these issues. Other examples for activities and research activities that the school can initiate, and we didn't have before, are workshops, working groups, international conferences that are interdisciplinary, done together by different scientists. And again, these are things that we didn't have before, like we are now planning to do. And these are just examples, and this is what the committee works on right now, to come up with new calls. And in the near future, there will be many calls, and we have the resources to support interdisciplinary groups within the university, and bringing in some leading environmental scientists. I'll go quite fast about on this one and move on to the graduate student direction or committee. Here, first of all, I want to say that we acknowledge many environment-oriented degrees and unique programs already existing at BGU, and we strive to connect and interact between these ones to make even a higher framework to allow students to know and to collaborate with other faculty members. We are now working on 3 new master's degrees, MA, MSc, and MA for directors in sustainability. And the idea is to have a tailor-made new programs that will allow students to be advised by faculty from different faculties in a much easier way than it is allowed or can be done right now. PhD scholarships for excellent students. This is something we have already done. We granted 2 months ago new 12 scholarships for excellent students and 8 for excellent master students. And we're going to do that. We got a contribution for that specifically for the coming years. Workshops and trainings, undergraduate students, we have, for the first time this year, we have new environmental study units. This is really new, and we did something that we haven't done before. We allow students from almost all academic departments, undergraduate, to take environmental study unit, which is 28 credit points, something like 1/4 of their total credit points in environmental study unit, one of the 5 that you see in front of you. This is absolutely new, and they take courses from different faculties and departments. The university worked quite hard to break all the walls and the paperwork and bureaucracy, and they can do that. And this is really new, not only at BGU. As far as I know, this does not exist in any other university in Israel. So now students from politics, for example, department, can take a credit and environmental study unit in life science. And they can put these things together, which allow them to know better about sustainability. I will run a bit. 2 new bachelor degrees, BA and BSc in sustainability. This is what we are finalizing these days, and I hope it will be approved in the next couple of months. And these are the game changer. This is what I'm dreaming of, not me, many of the school faculty members. If we have new programs, new degrees for undergraduates in sustainability, it will be the first time in Israel this way. And that will be the game changer. I think BGU University will definitely lead this field in Israel due to the new establishment of the school. And
Hey, you're on. Try to wrap up because we want to get to Sigal and Osnat. We're getting a lot of questions.
Great. Okay, outreach. So I'll do it fast. We're already working with many organizations outside of the university. We have Knesset members coming in, ambassadors, and so on. And we're talking with the government. A lot of things are going on already 5 months, and already we have a lot of attention, and people really want to collaborate with the school and BGU, and this is really good also for marketing. Again, just this is the last one. Basically, these all directions are not independent. We want the students to be involved in all the activities. We are talking about interdisciplinary, across subjects interactions, across faculty. There is no change in the university's academic organization, so faculty members do everything they did before, but now they have another framework in addition, not instead. There is no competition to the academic activities, and we already see the benefits and we enjoy it. And the resources anyhow go back to the faculty members in the different departments and faculties, so it belongs to everyone. So the idea is to hug and allow faculty members to do a better job in order to move on with sustainability and environmental research. Thank you very much.
Thank you very much, Yaron. One question, we're getting a bunch of questions, and I'll get to most of those at the end. But one that's coming up is how much of this coursework will be taught in English versus Hebrew, and will the programs be open to international students or just Israelis?
Wonderful, wonderful question. I am very happy it was asked. For the graduate students, we plan that most of the degrees will be given in English, like many other programs at BGU. And this is definitely something we want to do, and we have the support of the president and the rector. For the bachelor's degrees, on campus, it will be mostly in Hebrew because we have some limitations, but we are going to offer some courses in English. Actually, just recently, this year, for the first time, students on campus must take at least 2 courses in English. So we're going to have a mixed collection of courses in languages, and overseas programs will be given, but I think that the Institute of Desert Research will also be quite dominant with this respect, and they have their own machinery, which is wonderful already.
Thank you very much, Yaron. Your passion is palpable, and I know this school's been a vision for BGU President Professor Daniel Shamovitz, and the Rector Chaim Hames has been working very hard. So we're just really thrilled with your leadership to make this a reality. It's just incredibly exciting. I want to quote a text I just received from the board president of Americans for Ben-Gurion University. He said, "This is awesome," from Gary DeBode. Okay, Professor Sigal Abramovich is the chair of BGU's Department of Earth and Environmental Sciences. She is a marine geobiologist who specializes on single-cell marine organisms called foraminifera, if I pronounced that correctly. Sigal's interdisciplinary approach combines geological and biological research, which is implemented in her research projects. Her research extends beyond the purpose of expanding our knowledge of past and present oceanic conditions by targeting a near future perspective for the usage of foraminifera as model organisms for monitoring marine environments and global change. Sigal received her undergraduate and master's degree at Ben-Gurion University, and she received her PhD and did her postdoc work at a small school in the States called Princeton. She studied at the Department of Geosciences under the supervision of the famous Professor Gerta Keller, a world-renowned paleontologist. Until recently, Sigal served as the president of the Geological Society of Israel. She was born and raised in our own Beersheba, and her partner is also a scientist and professor of at the Life Sciences Department at BGU, and they have 2 daughters. Welcome, Sigal. I see you've got your PowerPoint loaded, so tell us about your incredible work. Thank you.
Thank you so much for inviting me. Thank you, Doug. First of all, happy Hanukkah for everyone. Before I begin my talk, I would like to say a few words as a new chair of the Department of Earth and Environmental Sciences, specifically on how our field is strongly linked to the new School of Sustainability and Climate Change. Nowadays, geologists, or how we like to call ourselves, earth scientists, are not only specialized in traditional field work. Our scientific scopes also encompass everything from documenting the effect of human-caused climate change to designing alarms against natural disasters and creating solutions for renewable energy. And indeed, our faculty members are making the utmost efforts to contribute to each of these scopes. So this is my message as the chair. Now, I'm indeed a geobiologist, and I'm specialized in investigating single-cell marine organisms called foraminifera, and me and my colleagues all over the world are trying to promote their use as the most important bioindicators of human-induced changes in the ocean, what is known as Anthropocene. Foraminifera have been around on Earth for hundreds of millions of years. They are among the most ancient and abundant fossils, and their shells, which are made of mineral calcite, are accumulating in massive numbers on the seafloor, creating these magnificent geological archive that are called chalks that are found throughout the world. And one of the most important contributions of foraminifera is the fact that we can measure their shells geochemistry and use them as the living loggers of climate change. As you can see in this film taken in my lab, foraminifera, when they build their shell, they incorporate seawater and they precipitate their calcitic shells directly from the seawater, therefore recording the ocean chemistry. So scientists over the years have developed a number of very important geochemical proxies that allow us to reconstruct climate change as well as other environmental parameters. As you can see in this figure, this is a reconstruction of Earth climate over the past 65 million years ago, based on stable oxygen isotope analysis of foraminiferal shells. So this is a very important proxy, just one example for that. Now, as Doug said, I was trained in Princeton, and I started my career by investigating the dinosaur extinctions 66 million years ago at the end of the Cretaceous period. And here is me together with my advisor, Professor Gerta Keller from Princeton in Madagascar. And we've been all over the world investigating the dinosaur extinction using the deposition of the shells of foraminifera, fossil foraminifera from all these places that are marked here in the map, and using their shells geochemistry. And when I came back to Ben-Gurion University, I continued my work on the dinosaurs extinction beside of the work on living foraminifera. And this drawing was made by the daughter of one of my colleagues from Jerusalem, Galia Rosenberg, who suggested the new graphical abstract of a recent paper showing a dinosaur drinking coffee next to a volcano, which basically resulted in their extinction. So going back to living foraminifera, we are trying to promote their use as an ideal model organism to monitor responses to global climate changes as well as anthropogenic pollution by studying them directly from the field and in our labs. And just for the general knowledge, foraminifera are grouped into two distinct ecological groups: planktonic foraminifera, which occupy the upper part of the ocean water, and bentonic foraminifera that live on top or inside the bottom of the sediments of the bottom of the seafloor. Now, in my research on living foraminifera, I'm focusing on a specific group of bentic foraminifera or bentonic foraminifera that harbor algal symbionts, another single-cell algal symbionts that live within their cell, creating a unique holobiont system which is highly sensitive to climate change. And these specific species, and you can see here example from the Negev of nummulites. These are famous large benthic foraminifera from the Eocene period. They typically inhabit warm tropical, subtropical environments, such as the one found in Israel. And because of their very large sizes, remember that these are single cell organisms, they are considered as major calcium carbonate producers and ecosystem engineers, similar as corals. Now, Israel is I think is the most ideal location for studying foraminifera. I'm not biased. We're in the middle or in between two very different oceanic provinces, the Mediterranean, which is a relict of the Great Tethyan Ocean, and the Gulf of Aqaba Eilat, which is a tectonic branch of the recent tectonic branch of the Red Sea. So we have an opportunity to study two very different oceanic provinces in respect to global changes. Now, in my lab, we are using a multidisciplinary approach that combines fieldwork that include taxonomy, ecology, environmental monitoring, as well as physiological experiments where we bring the foraminifera from the field and we culture them in the lab under specific environmental conditions that we can monitor. We also use geochemical analysis using laser ablation ICP-MS analysis, and now we can do that in our own lab here at BGU. We have a new lab that was established just last month. And we also do molecular analysis of the DNA and RNA that allow us to explain some of the physiological behavior that we see in the field of foraminifera that we see in the field or in the lab. Now, as I said, we focus on shallow coastal habitats, which are favorable for these type of foraminifera. They are extremely abundant in these environments. And these environments are not only important because of this, they're also strongly influenced by coastal industry, which are heavily present here in Israel. So we have the opportunity to study global stressors as well as local and regional stressors. And these environments are technically accessible, so we can reach there quite fast and then come back to the lab. Now, the Eastern Mediterranean makes a really interesting case for global warming, as you can see with this famous graph or figure. The 1 degree anomaly already persistent at the beginning of the 21st century, basically shows us that the Eastern Mediterranean not only follows the global warming trend, it also much more enhanced in this region. Now, the global response or the biotic response to this warming was the well-known invasion of tropical species into the Mediterranean from the Indo-Pacific province of many different types of species, which are known as the Lesepsian invaders. They are invading to the Mediterranean through the Suez Canal. And Israel, in that sense, is the coastline of Israel is a hotspot for these species that have spent the last 10 years or so to investigate the Lesepsian invasion of foraminifera and their ecological role in these environments. Now, another special thing about the Mediterranean that we have some places that we can use as a natural field laboratory to study global warming, such as the one presented near the city in Hadera, when we have a power plant which create a local heat anomaly, in addition to a desalination plant that causes an increase in salinity. And here we have an extreme scenario, some even unrealistic, of global warming that combines both elevated temperatures and elevated salinity. So here we chose two stations, H2, that represent extreme scenarios of 10 degrees warmer than the ambient environment, and H4 that represent only 1.5 degree warming, and another site near Kibbutz Nachsholim, which represent a control environment unaffected by these heat patch. The first thing that we've done is ecological survey of the foraminifera living in this environment, and this statistical analysis show in a plain way what we've got. Basically, most species avoid Hadera, even though they're considered as tropical species. But what was most interesting that this red group here, they actually were found in the most extreme warm environment. So they seems to be very tolerant or highly tolerant to these extreme conditions. So the next thing that we've done is to try to understand whether these species are actually, so they're just surviving these extreme environment, or they're actually able to live and preform under, and preform means being a foraminifera to calcify, to produce a shell. So here we use a geochemical approach and we analyze these species, and you can see these laser dots that were taken from different parts of the shell. And we use what is known as the magnesium calcium proxy for paleotemperatures that allow us to reconstruct the sea surface temperature when these foraminifera produce their shells. And by that, we discovered that these foraminifera that were collected alive from the field throughout the sampling year, they were actually able to, they produce some their shells in the summer under 40 or 42 degrees, meaning that they are able to calcify under extreme warmth. And this was unusual and unknown before this research. What we didn't expect, and this is very interesting, is that while we got the profile, the geochemical profile, the Excel file from the machine, we discovered traces, clear traces of heavy metals together with the magnesium calcium data of heavy metal that are considered harmful. And we didn't expect to get these heavy metals in the shells, because these metals were not absorbed by the regular monitoring of these sites. So this was very surprising to find them there. What was more surprising, that we find it also in Nachsholim, which is considered as a natural reserve area. So we clearly, we understood that we have a very sensitive tool, a new tool for discovering heavy metals by recording the geochemical properties of the foraminiferous shells. So the next thing that we were very excited about that. So the next thing that we did is to calibrate the concentration of these metals in the shells to the water, to their concentration in water, by doing a culturing experiments under known concentrations. And we done that for 2 metals, and we have a long work to do this for the other metals as well. And we also culture the foraminifera. We run several physiological experiments to study, to understand whether foraminifera are able to serve as a tool for monitoring heavy metals, if they can survive concentrations of very, very high concentrations of these metals, and they do. The next thing that we've done just recently, and this hasn't been published yet, is to follow up the oil spill event that occurred in February 2021. And what you can see here is a plot that was just created a few weeks ago. And it shows the level of lead, which is marked by the line, by the yellow line here, compared to the record now in 2021, in February 2021, compared to the records measured in 2013. So we can see here a very strong footprint of the oil spill event recorded by the foraminiferous shells. So this tool works very well. One last last sentences about the physiological culturing experience that you're doing. Here we are able to separately evaluate the foraminifera and their simian well-being at the same moment, actually. And we're doing that by measuring the change in the chemical property called total alkalinity of the seawater where the foraminifera are cultured, as a proxy for how much calcite they're producing, as a mean as a proxy for the well-being of the foraminifera. And for the algal symbionts from the same water, we measure the oxygen concentration as a proxy for the net photosynthesis, meaning the performance of the algal symbionts. Just one example of paper that of research in a paper that's coming up very soon, showing an investigation of these tools where we combined measurements of salinity, high salinity, and high temperature. We saw a synergistic effect of both stressors, and the result basically showed us that the future population of foraminifera in tropical spaces would be replaced by species that are more resilient to high temperature and high salinity, but they are not as good calcifier as the ones that are present now. So we expect a major drop in the ability or the contribution of foraminifera as carbonate producers. So this is my message, and I just would like to thank all my amazing students and collaborators all over the world. And this is the list of the people that I like most in my life. That's it.
Thank you, Sigal. That was very interesting, but also very sad. So hopefully, with this new school and of sustainability and climate change and your continued research, we'll find solutions to the challenges that are facing the foraminifera. Okay, so I think we've got another poll question, I'm told. So Melody, load up the poll. How much does the Dead Sea's water drop every year? 2 feet, 3 feet, 5 feet? This one, the answers came in almost a third, a third, a third, but the audience does win. Yes, the Dead Sea's water level drops about 3 feet per year. And that brings us to our next speaker, Osnat Gillor. Welcome, Osnat.
Hey.
We're very excited to have you today. Maybe we'll talk a little bit about the Red Dead project, but I know that you are the head of BGU's Department of Environmental Hydrology and Microbiology at Ben-Gurion University's Zuckerberg Institute for Water Research, which is part of the Blausteins Institute at our incredibly beautiful Stebocare campus. Osnat has a broad set of research interests ranging from the role of antimicrobials in biofilm formation to the diversity of soil bacteria and their role in the ecosystems. Osnat received her bachelor's degree from Tel Aviv University and her master's and PhD from Tel Aviv University for her bachelor's and master's, and her PhD from the Hebrew University. She did her postdoc work in the States at Yale and UMass. Welcome, Osnat.
Hi, thank you. Thank you for having me. Happy Hanukkah, everybody, and thank you for joining this webinar. I'm going to give a more broad description of our institute. We are at the Zuckerberg Institute for Water Research, and I'm going to talk a little bit about water research. So basically, we are trying to face the challenges of water treatments in our changing world and trying to tackle that from different angles. And I'm just going to give you a little bit, some tidbits about what we're doing. We will be happy to tell you more. So what we're doing is we're trying to take treated wastewater and look at the treated wastewater and their different or the different uses of treated wastewater, either for irrigation or for discharge into polluted river, and what happens in the river, what happens in the sludge, what happens when the water are leached into the soil, and what happens when we want to desalinate this water and use it for drinking water. And I'm going to show you a few examples of what I just told you about, of what this kind of cartoon is showing. And basically, we're trying to study water treatments and different applications, and we are doing it in a very collaborative way. So we are trying to collaborate as much as possible, looking at it from a lot of different angles. So the first study that I want to talk about is done by the head of the Zuckerberg Institute. That's Amit. He's on the right top corner. And he's working on gray water recycling systems, so decentralized wastewater treatment systems, where he's trying to look at how can we have a home or a domestic wastewater treatment system. This is a example of this system where he's looking at plants and tuff and lime pebbles that are treating the water using mechanical and biological treatment, it's being gathered in the bottom tank, and you can see here how it looks like. So what you can see is the upper tank here on the top with the plants, and here in the bottom the water is collected, and the water is used for irrigating yards, and it's irrigating many of the yards in stable care community, and it's being tested and studied by Amit for many years now. Another thing that we're really interested in is what happened to the wastewater.
Osnat, I know that it's well known that Israel leads the world in desalination, but also by far leads the world in water, recycled gray water, correct? Over 80%?
Actually, not really. 80% is domestic wastewater, so centralized wastewater. That's the water that is being treated in central water treatment plants. Actually, there are a few issues with gray water. We're testing that. It's being kind of a pilot testing of the gray water. The country that is or treating most of its gray water is actually Australia, where about 60 to 70% of the domestic gray water, it's not all the wastewater, so gray water, just to kind of touch base, the gray water is all the water in the home, excluding the black water, so the water from the toilet, and usually the kitchen water. So we're not using that, we're not treating that, we're only treating the water coming from the shower, from the washing machine, from other sources in the home, and then it is used usually for yard irrigation, though there are other uses as well.
Thank you for that clarification.
Sorry, I'm sorry it wasn't clear. So what we are also interested in is looking at stream restoration. This is Shai, and he's working on stream restoration. So the streams are, some streams in Israel are highly polluted. One of them is the one in Tel Aviv. This is the Yarkon stream, and it's in Tel Aviv, and it used to be a very polluted stream. Through efforts of many years now, it's being treated, and it's transformed into a much cleaner stream right now. And Shai is studying stream restoration through by downscaling it from the catchment area, so from very, very large scale to the benthic area to up to the cellular level. And of course, there are many collaborators that work together with him to understand how can we restore the water and restore streams. And in Israel, because we are an arid country, what we mainly use for these streams is wastewater. So it's wastewater discharge that is discharged into the streams, and then they're being and then we have to have like ground rules of what kind of treatment should we apply, what kind of contamination could occur, and so forth. And Shai is studying that. And another very interesting project that is kind of related is what happens to the water when they leach through the vadozone or through the soil. And for that, Ofer, you can see here, is using these pipes that you can see up here. These pipes are being introduced into the soil all the way through the soil and up to the groundwater, if it's polluted groundwater, and you can do it in various areas. So either municipal areas or beneath gas stations to see what happens to leachate of gases, of petrol and other contaminants. He's doing it under landfills to see what happens in landfills, especially landfills that haven't been treated or very, very old landfills and so forth. So trying to see not only what happens in the groundwater, but what happens in the transfer from the surface to the groundwater. We're also really interested in desalination. We have a desalination department in our institute. And of course, just to clarify, so desalination could be either desalination of seawater, but it could also be desalination of brackish water or wastewater. In Singapore, for instance, they're mainly using wastewater, and they're cleaning them up to, or treated wastewater, and they're cleaning them up to drinking water. And here in Israel, we have a lot of desalination of seawater, and we're trying to tackle different problems that occur with desalination. So one of them, this is Chris Arnish, and he's trying to fabricate new membranes that would facilitate the desalination. So desalination is requires a lot of energy, and maybe using different membranes or different matrices, this could be mitigated. And here he's using graphene, which is a carbon polymer, and he's both fabricating it in his lab, 3D or using 3D, and he's scaling it. So from a very, very small scale up to much larger scale, like the pilot scale that we have in our institute. We're going all the way. I'm not telling you about all the other people working on different aspects of desalination, but we go all the way, and Sigal was mentioning that, looking at what happens when we discharge the brine into the sea. And this is in the Mediterranean Sea, and this is Ido, and he's working on what happens. He's testing the water around this brine discharge, the salt that is discharged when after desalination. And we can't ignore the COVID. And so this is Uded, and he, with the COVID, started a study looking at or trying to detect and identify CoV-2, SARS-2, the virus in wastewater as a monitoring system for a COVID in the community. And so they were going around during the first outbreaks of the COVID epidemics, and they were testing wastewater systems and finding ways to concentrate the water and look for the COVID in the water, such that, and then they can map areas, cities, neighborhoods in order to see whether they can detect the COVID, and then whether the coronavirus, and whether they can then locate it where it's coming from. The last thing I want to tell you, and I'm sorry it's very fast, but I know it's late, is about the outreach we have in our institute. So this is the primary school kids, and they look at the effect, primary school kids from the local primary school, and they look at the effect of water quality on plant growth and greenhouse gas emissions. And we're also working with the high school students, looking at bioremediation of water treatment. Amit, I mentioned it before, also built in the local high school an aquaponic system. And just briefly, this is a system where there is a fish tank, we're growing fish. The water that is used to grow the fish is being treated, and then it's being used for hydroponic cultivation of plants. And this is a zero net system, so the system where the water is being recirculated within the system and are used for the fish, treated for the hydroponic, and it continues to circulate within the system. We also have a very interesting project where we want to expose high school students from the Bedouin community. So we have a large Bedouin community here in the Negev, and we want to expose them to science. It's very challenging to expose these kids to science. And we have this project, this is the third year of the project, where we meet the children and expose them to different projects within our institute. Our students are engaged in this project. And the last project that I want to show is the project that Noam, the head of the institute, the head of the institutes, the Blauston Desert Institute, is conducting in Africa. He didn't do it in the past 2 years due to the COVID, but before that, he was teaching a course called Rural Water Development course, and then the students would go to Africa and would help drill water for and use them for the benefit of the community. And you can see here students in 2015 in Uganda drilling in this area. And this is one of the kind of, it's a very interesting project because it's bringing our students into these rural areas and understanding the rural or the needs of a community and how to facilitate that, both in many ways, both the water, treating the water, and testing the water, and they're developing different methods to do that. So that's about it. I'm sorry that I went over time, and I'll be happy to take questions.
Thank you very much, Osnat. We've run over our hour, so I'm going to try to close this up. We have a number of questions. If you asked a question and we don't get your answer, we'll do our best to get those answers to you individually. But Nechama Sigal asked a really good question, Osnat, which is, what are the possible impacts on human health from these various projects, and how do you go about researching those impacts?
Okay, so I'm glad you asked me because this is I'm a microbiologist, so I'm actually looking at the health aspects. I didn't talk about my work, but what we're doing is we're testing both. So we're testing various aspects of that. So we're both looking at pathogens and indicators. So pathogens at various levels of pathogens, so both bacteria, protozoa, and viruses in the water, in the different water. For instance, we have a large project looking in gray water for different pathogens and different indicators. We're also looking for antibiotic resistant genes and bacteria. And we're looking at different contaminants, emerging contaminants from PFAS all the way to endocrine disruptors and so forth. So we're trying to cover these health effects, and we are trying to look at the kind of challenging health effects that are both afflicting places like Africa, like you see here. So then we try to use low tech in order to look at the health threats that might be associated with the water, up to looking at, as I said, PFAS or endocrine disruptors in the stream while we do stream restoration.
Thank you very much. Maybe you could stop share on the PowerPoint?
Oh, sorry.
No problem. Okay, well, we are over our hour, so I'm going to try to wrap it up. As we promised the audience, an hour-long program, although our participants have held on. We're losing a few now that we've gone over an hour. But we have one final poll question, and then we'll close everything. Which of the following things did David Ben-Gurion predict? It is in the Negev that the creativity and pioneering vigor of Israel would be tested. If Israel was to succeed in desalinating seawater, it would bring a great blessing to the entire human race. And also that the future would have a huge importance of using wind power to generate electricity. And our audience was smart before they took this webinar and even more educated afterwards. Yes, 2/3, all of the above. David Ben-Gurion was a true visionary. We lovingly refer to him sometimes as the #2 Jew all time. And the university that carries his namesake takes great pride in turning his vision into a reality, as demonstrated by the unbelievably terrific work of Yaron Ziv, Sigal, Abramovich, and Osnat Gillor. Okay, so I think this is a wrap. I'd love to keep going, but we're going to have to bring this program to a close. So this was a wonderful webinar on BGU's new School of Sustainability and Climate Change, a dream that is now a dream of Professor Daniel Shamovitz, Ben-Gurion University's president, that is now becoming a reality under all of your leadership. And thank you to Chaim Hames. I also got a note along the way from Jeff Kay, just reinforcing that the Council of Higher Education is looking at funding for English-speaking programs on our Stabo Care campus. I think this is a topic where we may need to do a few more follow-up webinars because there's been so much interest. And with that, I will just close with a little mention. If you'd like to support our work of this new school, you can do so by texting to this number 844-954-4648. Just text the word donate. Also, for those of you who know, the day after Friday, last Thursday, Thanksgiving was known as Black Friday. Today is Cyber Monday, and tomorrow begins Giving Tuesday. So if you're active on social media, we have a campaign. We'd love people to participate. I know I have over 3,000 friends on Facebook. I've made a pledge to donate $18 to every friend of mine who shares this campaign on their Facebook page. So if 1,000 of my friends share, that's going to cost me $18,000. So please look on social media and share our campaign. David Ben-Gurion also once said that it is incumbent upon Israel's scientists to reveal the secrets of nature that are unique to our land, especially the unique elements of the Negev desert. And once again, I just thank Yaron Ziv, Sigal Abramovich, and Osnat Gillor for joining us today. Chag Hanukkah Sagmeach, happy Hanukkah to everybody, and keep up your great work. It's time to go to bed soon, almost Laila Tov time. It's 8 p.m. in Israel. So thank you for joining us. Stay safe, everybody, and be healthy.
Thank you. Have a great day.
Thank you.
Happy Hanukkah.
Hanukkah Sameach.